and it gives you the position of the ship, okay? It gives you the position of the people, gives you the helicopter. Now notice what we have here is one of those same pictures. We have this right triangle with a line coming down at the altitude, so we end up with 2 more right triangles. And what we want from that is that they're similar triangles. Before I separate them into individual drawings, one thing I want to do is fill in any information that I can. Okay, so I really don't know. This is what I want to find. That's my X. So I'm going to go ahead and label that as X before I split off into my individual pictures. Okay. Then, is there anything else that I can fill in? Well, I know from this distance is 2.3. The whole thing is 2.8. So what would be the distance from here to the boat? We can just use subtraction to find that. But like I said, before I pull everything apart, I want to go ahead and find that distance. Good, it's 0.5. So we just took 2.8 minus 2.3. We found this would have to be 0.5 miles. Okay, now I'm going to break it into my separate triangles. So I have one triangle here, and I have another triangle here. So just like we did when we were naming our parts, I'm going to break those up. I'm going to do the pink one on the right first. Okay, so I'm going to just draw it, and I want to draw them in the same direction, just because they're easier to work with. That way it's hard to match up the parts when they're in different directions. Okay, so this one had, this side was X, its short side, and its long side was 2.3. Okay, now I'm going to draw the blue triangle. Oops. I'm going to draw it that same direction, so it's smaller, but it still has that short side, the long side, and the right angle. So for the blue triangle, what was the length of the short side? Is it the 0.5 or is it the X? Just so I label my picture correctly. Okay, so look at it. Which side looks longer? This one or this one? Okay, so notice this side is shorter. So that's going to be my 0.5 is my short side. And my X is my long side. Okay, I don't have to draw the big triangle for this problem. It doesn't have enough measures. All I know is the measure of its hypotenuse, and that's not going to do me any good. I'm going to use these two pictures to set up an equation. Now, our property said that when we have these, they are similar, which means when we put the same sides in a fraction, they're equal to one another. Okay, so if I take the short side of this triangle and put it in a fraction with the short side of this triangle, and I would do the same sides. You want short with short, okay? It should be equal to the long side of this one, which was 2.3, over the short side, or the long side of this one, which was X. Okay, do you have questions about that? Because I know that's kind of a leap right there. Because way back at the beginning of the semester, we talked about similar triangles, and what that meant was that you could put their same sides in a fraction and they would be equal. So if you put this, the corresponding sides is what they're called. So this short side and this short side in a fraction should be equal to the long side and the long side. So that's how we set that up. Okay, now to solve our problem, all we have to do is solve this equation. Okay, so can you think of how we might start solving that? Very good. Cross multiply. Good. So we cross multiply. We leave our equal sign in the middle. We get x times an x would be x squared. And then we have 0.5 times 2.3. So we go ahead and we do 0.5 times 2.3, and that gives us x squared equals 1.15. Okay, we're almost done. How do you get rid of a squared when you're solving an equation? Okay. We can't really divide because we'd have to divide by an x. What we do, the opposite of squaring, is to do the square root. So we would take the square root of both sides, and that would get rid of our x squared. So our answer is going to be whatever the square root of 1.15 is. And I get 1.07. It goes on from there, but okay. All right, so questions about that one? They kind of threw you kind of in the deep end on that one and said, go from drawing pictures to solve this big problem. So, okay, so you have a question about any of the steps? Okay.